Hello, everyone. So, welcome to our Fireside chat on Zero LB. My name is Cody. I work for Kong, and I do service mesh, and I'm here with Marco, the CTO and co-founder of Kong. Marco, how's it going, buddy?
Pretty good, pretty good. Thank you, Cody, and hi, everybody.
Yeah. So today we wanted to jump in. We have big new release coming out for Kuma and Kong mesh, which is pretty exciting. But we've got this thing that we've been starting to circulate around a bit and talk a lot about, and it's this concept of zero LB. I'm going to unpack what that means in just a moment. But before I dive into that, I think that what's really interesting about the service mesh space is, and we talked about this when I came aboard several months back, Marco. Like, it feels like service mesh is right around the corner from hitting its stride, and we're starting to see like a crazy uptick in the amount of people who are like really doing production things. I think the community has been playing with service mesh and taking it for a spin and kicking the tires, but we're actually starting to see like businesses solve actual problems with this and like start to use this thing as a platform to solve bigger things than just throwing WordPress up in a Kubernetes cluster and linking it together. So maybe you could talk just a little bit like what you're seeing kind of market wise when it comes to service mesh and like the uptick in the enterprise. You get very hands-on. It's something I love about you is that you get really hands-on with our customers and making sure that they're actually successful with this. So I think everyone would be really interested to hear, like, what are you seeing? What's like some of your big insights that you're discovering about the way enterprises are using it?
Well, so one of the things that's quite interesting about service mesh, it is that it has not been a very well-defined category for a very long time, in a sense that service mesh, it is not an end per se, it is a mean to an end. And so what we're trying to do here at Kong by looking at the adoption we've been seeing with Kuma and with Kong mesh, it is trying to refocus on the end use case that service mesh allows us to enable. And some of them are around observability. Some of them are around security and zero trust, being able to provide an identity to all of our services. But another very important use case that we actually haven't thought about in the beginning, and we're seeing it being implemented with our customer base, truly is this idea that centralized load balancers have really no place in a decentralized architecture. And so this is really something that we've been investing a lot in the past few months when it comes to the products, when it comes to being able to understand these use case. And we came up with this new word. And by the way, this is not specific to any Kong product. It is more of a pattern that we're seeing in the industry. And that pattern is called zero LB, removing load balancers in front of our services. And when you look at that, when you look at this specific use case, this is actually a quite exciting use case that can allow us to improve the performance of our services and the entire user experience, as well as being able to save tons of money, because now all of the organizations that are deploying zero LB, they don't have to run either cloud load balancers or enterprise load balancers in front of their applications. So service mesh is quite exciting. What excites me the most is the use cases that enables. In zero LB, it's certainly one of them.
And I think that what's really cool about looking at the zero LB thing is that, we jump in and we talk about the technology a lot, and we talk about like, oh, you can automatically apply MTLS policies across your environment. And like for people who are deep in that space, like that makes sense. And they're like, okay, I get it. Cool. But I think that any of us who have worked in the enterprise and architected, like I in my previous life, I used to build these services that would stretch across the entire West Coast. Like that was where all of our data centers were. We were a West Coast company. So like anyone who's worked in that space knows the struggle of starting to stitch these things together with load balancers. And it's not that like the load balancers themselves are very complicated, but it requires a lot of manual stitching. It's, Cody going in and setting up a bunch of stuff behind a VIP and then making sure that VIP is registered with DNS and making sure you're pulling certs based on that VIP. And then when you have another site, you're replicating those same steps, but with the odd numbered servers instead of the even numbered servers and these different IPs. And when you need to change one of those, it's a very like laborious task to go back through and say, okay, am I changing the primary side or the secondary side or the tertiary side? And then you start stitching, like, how do I handle this globally, right? Do I have like a global load balancer in front of it, like a GSLB or something like that? Where I'm going with this is like that model becomes very brittle, and we all budget for the time where we deploy a system, but like the change afterwards and the maintenance and upkeep is always something that we just have to figure out. So like what's exciting for me when I hear you talk about zero LB is like I lived this life and it was a very frustrating life and it was very challenging. And we spent a ton of money to figure out ways to automate it that never really like panned out very well. And being hands-on with mesh and understanding it a little bit more deeply, like many of those concerns just come off the table entirely because I can let the mesh handle this. And like 90% of the struggle that I had in that goes off the table. So it's like, it puts a practical picture on this idea of service mesh. Cause there's like 100 things you can do in service mesh to solve problems. But when you frame it this way and you say, hey, look, like you've struggled with load balancers, they cost a lot of money. They're very like sensitive in the sense of a number of things you have to do for them to do what they're going to do. It's nice to have this like framing around it of like, oh yeah, I get that problem. I get what it's trying to solve.
But and when you think about it, Cody, the industry has been going through this journey, not only of decentralization, but also portability. One of the biggest advantages that we have by using containers to deploy our software on portable platforms like Kubernetes and being able to run them across every cloud, every data center, it is the replicability and portability of our software. Every organization in the world, at least the ones I'm working with, they do support multiple clouds. They do have legacy data centers. And portability, it is an amazing strategic advantage. If anything, it's leverage with the cloud vendors and the cloud providers. There is no reason why we have decoupled ourselves from the way we package our software, containers, from the way we run our software, Kubernetes, and we're not doing the same for our traffic, our load balancing. Using cloud vendor specific load balancers, like the elastic load balancers that AWS or Azure provide, do not allow us to provide portable functionality across the board. When we think about it, load balancing, it is in between every single request that we're going to be making across the board. Not only a centralized load balancer is going to be adding an extra hop in the network, therefore is going to be making our microservices slower. And with microservices, performance, it's all that matters. If the microservices are slow, the end user experience is going to be slow. So performance becomes a first-class citizen when it comes to microservice architectures. So not only we're adding a new extra hop in the network that will make the request slower, not only we're going to be adding processing latency in between every request, but we're also lacking portability across different clouds. Therefore, we're going to be having a situation where load balancing in one cloud is going to be different than load balancing in another cloud, which is going to be different than load balancing within the data center. Forget about the fact that centralized load balancers are some of the things that we take for granted that has never changed in the past 20 years. And the technology itself is quite outdated. Today, with modern decentralized load balancing, we can dynamically configure across the board, leveraging a service mesh, client-side load balancing across multiple algorithms, load balancing that's self-healing across multiple regions and multiple clouds. Forget about the cost benefit. Forget about the performance benefit. The actual functionality, it is a much more mature and modern functionality for applications that can never go down. And having that sidecar proxy performing load balancing for us, as opposed to a centralized load balancer, looking back, it's inevitable. I mean, when we look back and we think of all the centralized load balancers we put in front of our services, why are we doing that now that with Service Mesh, we have the underlying capability of being able to inject smart load balancers across the board? Not only that, move them across different clouds, they're gonna work the same way. And when we build our software, we can replicate that same functionality in such a way that when the software ships in a better way with less bugs in the first place. That portability journey we've been addressing with our microservices journey in the industry, it's finally coming to load balancing. Load balancing, it's long overdue for a status quo change. And I'm very excited about Zero LB because it is really that change that will enable us to innovate faster and create better user experiences.
I think it's my snarky hot take is you mentioned in there, you're like, why are we still putting these load balancers in front? I think it's that common enterprise reason we hear always is because it's what we've always done. right? It's because like that's the architecture pattern. And like I remember coming in as like a junior admin and being told, oh, yeah, we always put our, even if it's one node, we always put it behind a load balancer because that's just what we do. But it's like when you take a step back and you look at, and we'll dive a little bit in without going too deep. We'll dive into like the tech of this and what's happening for 0LB in order for it to function. Because I think that'd be useful for the people listening in. But like when you take a fresh look at the problem and you say, hey, look, like, do we really need to do it this way? Do we need that single point of failure? Do we need to add these extra hops? Do we need to buy this thing that gets racked or thing gets installed in vCenter as a virtual appliance or deployed as a AMI and AWS? Do we need this extra spot to be just load balancing, or is there a better way? Like it becomes a very obvious path to it. I think something else you mentioned around portability, and it's a little bit of a path around. I think that there's a lot of interesting similarities between what happened with Kubernetes and what happens with service mesh. Kubernetes was never meant to be the destination. It was meant to be a platform to build on top of and to build things on top of. Just like service mesh isn't the destination, it's a platform that's designed to be built on top of, and it's built to become this networking layer that solves a bunch of networking problems or a bunch of connectivity problems inside of an environment. And I think that's really like a really interesting thing to think through as we look at these architecture patterns that we're introducing, like 0LB. Because it starts to really build that foundation of like, okay, cool. I'm taking a fresh look at how I connect these things together. And I'm making sure that I'm getting the most value out of the thing that I'm building. Because at the end of the day, you're not just getting 0LB out of this. There's an entire swath of capabilities, observability, the security stuff, the traffic control that you don't get in like a traditional hardware load balancer that's being dropped into an environment. Load balancing is kind of the bar, right? It's just we meet that bar by having load balancing in place. We support all of the complex algorithms for load balancing, so that box is checked. So when you move beyond that load balancing capability, you start to think about like, what else do I need out of my application connectivity? I need the ability to control traffic routing. I need the ability to do A/B testing. I need the ability to have good observability in there. I want security as a day zero thing. When you can add all of this stuff with the exact same level of effort as getting 0LB in play and getting like that client side load balancing out of service mesh, it really becomes a no-brainer. It's like, why am I not going to go this route, as opposed to dropping like infrastructure in to accomplish this, or pulling in a new load balancing service to handle this. Like it seems like a really obvious path to go.
And the nice thing about this, many architects or operators, they may associate microservices with containers and Kubernetes, but we are all very, very well aware of the fact that there is going to be other software that's not containerized yet, not on Kubernetes yet. And the nice thing about 0LB, it is a platform agnostic pattern. So we can implement a client-side load balancing that's smarter, that's faster, that's dynamic, that's portable, that's open source across both the new workloads and the new applications the teams have been building on Kubernetes, and still being able to provide the same capability to the other teams, the ones that are still running on VMs and virtual machines. And as a matter of fact, by being able to have a load balancer that can run across both VMs and containers, we can also accelerate that transition to the cloud and the transition to containerized workloads by using the load balancer as the decision maker on how much traffic goes to the legacy VM workloads as opposed to the modern containerized cloud workloads. So truly, like you mentioned, it's not just about load balancing the traffic. A decentralized 0LB load balancer is going to be providing all of these additional routing capabilities that's very close to the underlying service. 0LB, it's client-side load balancing being delivered by a sidecar proxy like Envoy that would allow us to essentially implement all these other set of features, the observability, the security, the A/B testing, the canary releases, the self-healing, the intelligent routing across both VMs and containers, across any platform and infrastructure. And guess what? We can do that by removing an extra hop in the network. Therefore, everything is going to be faster. And we're going to be doing that by removing the adoption of centralized load balancer. Therefore, everything gets cheaper. It truly is a no-brainer. When we look at the load balancing landscape, this was long overdue. Centralized load balancing in front of our services, in front of our application, can be decentralized and must be decentralized in a decentralized architecture.
Let's talk a little bit about that. Like, let's jump into, without going too deep into the tech, let's talk a little bit. We talk at Kong a lot about decentralized and this idea of like decentralized workloads. When customers come to you and say, hey, what does this mean? What does decentralized mean? Like, what does this architecture pattern actually mean for people? Can you talk a little bit through? I know it's a little adjacent to zero LB, but I think that we can use this to kind of transition into how zero LB does what it does. So like, what is decentralized? What's the best way to explain a decentralized workload? Let's use an example. Like, I've got this big application server in my environment, and that's what I run my app on today. And I come to you and say, Marco, help me turn this into a decentralized service. Help me out here. What's the path to that?
Yeah, well, so decentralized workloads provide benefits on many different angles. We decentralize our applications in different services because we want to be able to scale in a much better way. Obviously, monolithic applications are very painful when it comes to that. Everything runs in one code base. We want to duplicate and extract functionality in such a way that different teams have much cleaner boundaries between them in the way they work together. So reducing the team coordination, as long as there is an API and the API is a product, then we're going to be able to release our services as if they were products, and our customers are the other teams that are consuming those services. So it increases it reduces the team coordination, which increases the velocity of development, which allows us to ship products and features in a much faster way. And now, because each service is independent, we can also scale them independently, therefore provide better HA across the board. Decentralized architectures, it's all about not having all the eggs in one basket. It's about being reliable. It's about being able to replicate our infrastructure across multiple regions, multiple markets, to enter new markets, to be able to cater to our users in a much better way. The organizations that have, and with decentralized, we may commonly say, moving to microservices. That's really what I mean when I say decentralized. Now, in a decentralized world, our software, it's transforming. It's as if it was moving away from being a single cellular organism, and it turns into becoming this multicellular organism. Our bodies are multicellular organisms, and they're that way because they're reliable. We have multiple failovers. If something goes wrong, there is always another path to make that request. Likewise, our software is becoming more intelligent as a result of that. Now, of course, in order to be able to support this decentralization, we cannot think of microservices the same way we were thinking of monolithic applications. We have to change how we deploy the software, how we package that software, how we replicate all of this infrastructure across the board. Not only from a software standpoint, from a people standpoint, how are these teams going to be working together asynchronously in order to deliver the value that they need to deliver? How do we move into an API first organization where APIs, it is really what matters, not the actual implementation when I'm consuming these services? And when we look at all of this ecosystem, then of course, load balancing, which is in between every single and every individual request, also must be affected by this transformation. And in the industry, believe it or not, we are still deploying centralized load balancers in front of our decentralized services. Now, there is a place where centralized load balancers are very important when entering a data center or a site. I don't think we could, but I think that there is value in having centralized load balancers at the edge of our network. But within our infrastructure, when the applications and the services are consuming each other, we should not have a centralized load balancers in between that. I was speaking with a CTO of a very well-known and popular data analytics organization running in the cloud. And he was telling me, help me, Marco, remove 16,000, 17,000 elastic load balancers in front of my services and my applications, because not only they prevent us from being able to support other clouds in a predictable way, they're actually quite expensive besides the performance implications. We can get rid of that cost. We can get rid of the bandwidth cost that we're removing. All of a sudden, we're reducing the bandwidth by 2 or 4x. depending how you look at it, by removing those centralized load balancers. And we have a much leaner infrastructure. Service Mesh provides us then the underlying capabilities of being able to manage a fleet of these centralized load balancers. The same way we manage a fleet of these centralized services with Kubernetes, with our CI/CD. Likewise, Service Mesh, it is a mean to an end to deploy and manage a fleet of these centralized load balancers.
Yeah, so this is a good point for us to talk through kind of the nuts and bolts of the zero LB like concept and how this actually works. So when we look at, let's look at the traditional data center. We have a virtual IP that sits in front of maybe 3 or 4 application servers behind it. Maybe those application servers are hosting an API. To Marco's point, you've already broken down into microservices. You've taken that one server I talked about before. You've broken out the user service, the store service, the registration service. These are all different services now living in a microservice world. But you've stuck with that model of putting a virtual IP in front of n amount of nodes behind it. And people connect to that virtual IP. It uses maybe round robin, which is just cycles through the available nodes to drop traffic on there. That's a traditional existing kind of monolithic architecture of connectivity. When we look at what zero LB is doing, we're throwing a sidecar in front of every one of those instances. And that sidecar, we're not manually doing that. That's part of when we bring up Kuma or Kong mesh, that sidecar is getting applied to that workload. And what that sidecar is doing is intercepting inbound and outbound communication to that node. And that sounds really complex. It's not. All it's doing is saying, hey, send your traffic through me so I can do things with it. It's receiving its configurations from the service mesh. So from the control plane that's coming down to it and saying, hey, here's data about how connectivity works. And this is the part to pay attention to. This is the important part. Service mesh is designed to operate in a decentralized way. So those nodes become aware of everything else inside of the environment. They become aware of traffic policy, permissions, different configurations for metrics gathering. Specifically, in this case, the load balancing concept. So what it becomes aware of is the other nodes in the environment that match its service name or other service names so that it can reach out and communicate with those and it can handle its own load balancing. It can reach out to its destination node and say, hey, I need to send traffic to you. I'm going to send it to this node. What's really powerful about this is if we go in and we cut the line for the control plane, those sidecars already know about everything in the environment. You can't push new changes to them because you've lost the control plane, but because they're decentralized, they're still able to operate. They're still able to do that load balancing concept just out of the box. They understand service identity. Each of them have their own cert, their own identifier that indicates what those services are. They have their own DNS inside of the system that understands how to resolve that. All that's happening behind the scenes. That's something that you as an administrator has to manage or go in and add and remove. When you register these services, they're automatically dropped into the right bucket. That control plane update is done, and all of the systems know about the new addition to that. When we go in and we change that algorithm and we say, I want to go based off of a hashing algorithm, or I want to go least connections, that update is pushed again now. And those sidecars update themselves and understand, okay, I have a new algorithm to work off of. I'm going to select my destination node from here. It allows these services to operate independently. Once they receive their configuration, they manage their connectivity and they manage how to get to where they're going, as well as how to serve inbound traffic as well. This is how systems need to work in a decentralized world. When we have a data center living in Palo Alto and another one living in Beijing, like the traditional model of throwing these larger load balancers in front of that just doesn't translate to that world. Can you make it? Sure. Can you force it? Sure. Is there a lot of cool? Anything's possible with code time and a set of infrastructure code. Like you can do a lot of hacky things to make things work. The point is, you don't need to. It doesn't need to be that complicated. We have an easier way to do this inside of Service Mesh.
And perhaps one of the biggest changes that zero LB brings to the table, it is to think of load balancing not only as an ingress function, but as an egress function as well. Because essentially, when we deploy a zero LB next to our services, it's not only about the ingress anymore, it's about the egress. So we can really apply all the smart policies that you just brought up on both traffic paths, something that was not necessarily possible with a traditional centralized load balancer. I mean, the benefits are huge when it comes to the things that we can do. Now at Kong, we've done lots of work to make sure that this is easy to use, doesn't require any application change. So we can drop in a zero-LB infrastructure thanks to the service mesh that we've built. Kuma, the CNCF project we're contributing to, and Kong Mesh, which is built on top of Kuma. It's the product that we're shipping when it comes to service mesh. And really make sure that zero-LB is deployable across both the containers and the VMs, across multiple clouds in one click. And there's lots of innovation that went through it in order for us to be able to do that. The goal here is to make sure that load balancers become invisible to the teams, invisible to anybody that is making a request, but they are there. They're running at runtime in a decentralized way on both ingress and egress functions of our traffic.
Yeah, it shouldn't be. I think, like, at the end of the day, like, you shouldn't have to. This isn't something. Reframing that, we've made tremendous gains in technology, and we've done really powerful things in the past, 5-6 years of cloud computing, connectivity, all of this space. Load balancers shouldn't be something we have to worry a ton about anymore. Like, this isn't a problem that we should be dedicating administrator time, developer time, operator time to go and care, feed, and manage. We have enough intelligence in these systems to manage this. Like, Envoy is wicked powerful and can do all of this itself. To your point, we're not talking about taking these out of the DMZ for inbound north-south traffic in the environment. Those serve a specific purpose that's way beyond, truthfully, way beyond load balancing. Like, that becomes a place where we're handling security concerns. Like, I get that. But within the data center walls and intra-service communication, like, you don't need to go this, like, the traditional load balancing path. Like, there's a better way that's going to get you way more than just load balancing. Load balancing should be something you don't like. It should just be an assumed thing at this point. It should be an assumed thing that the system handles for you, because ultimately it's the right way to do things. If you're not load balancing a system, you just don't care about the service that you're hosting. Like, if my WordPress joke earlier, if I'm throwing up WordPress to show something off, like, I don't need that load balanced. I'm just playing with it at that point. But in your data center, you're always going to load balance things. And if you're always going to do something, why should it be a hyper complex thing? That should just be a system assumed thing that has that capability there for you. And that's what we do inside of Service Mesh. I'm a fan of removing complexity. I'm a fan of making things simpler for users. So we're running up on time. I want to put a little pressure on you, Marco. Where's this going for Kong? Like, we can't always talk about all the features we're putting out for a lot of reasons, but, like, can you drop some tidbits of what our vision is around making this a more full-fledged thing? How do we continue this journey on? What are we doing in the product to make this better for people?
Also, we are already working with enterprise organizations in their journey to remove centralized load balancers away and bake decentralized zero-LB load balancers via a service mesh like Kong Mesh into each and every service that the teams are creating. So we've been doing lots of work when it comes to enabling the use case, when it comes to educating about this use case, when it comes to providing dynamic load balancing capabilities that provide security out of the box and observability out of the box without the teams having to change anything in the way they write services or build their applications. And we're going to be doubling down on this use case. I mean, this is obviously an opportunity for all of us to improve how we build software and how we ship software to the end user. And there's going to be a lot that needs to be built still. And I'm very excited about the upcoming roadmap. More reporting around load balancers and zero-LB, more self-healing and intelligent capabilities in such a way that our traffic never goes down. My goal is to turn our service mesh into the ways of software connectivity. When we drive home to the office and there is a traffic jam, Waze redirects us to a different route in order to reach our destination. Well, with that decentralized load balancing capability, we can do that, but for our software. We can make our architecture look like the ways of service connectivity. Always up, always reliable, always ongoing, self-healing. And so this is really the roadmap and the vision that we're executing against. And so I'm quite excited about seeing all the next features and releases that we're going to be shipping, and also seeing the customers, deploying them in production for real world use cases. Today, if zero-B capabilities that we provide were to stop working, for example, just an example, air travel in North America would collapse. So these are the kind of mission critical use cases that I'm very excited to be partnering with our customers to work on. And so I'm looking forward to seeing more and more of them.
Yeah, just to wrap up and kind of close out, to use your Waze example, I know when I go and look at cars now, when I like maybe debate a new car, I'm always checking to see what integrations do I have in like the dash system, right? Like what type of things am I going to get? Do I have navigation? Imagine a world where when you get in every car, Waze is just a default, right? You get in, you plug in your destination, and it tells you how to get there, and that's just an expectation from the ground floor. Like that's a huge value add, and that's a huge like capability that if I just knew that was in every car, it makes that so much easier to decide between. That's what you get with service mesh, and that's what you get with us chasing zero LB. So I'm pretty excited for it. Thanks for taking the time today to hang out and talk through some of this with the community and with me. This was fun.
Thank you, Cody.
All right, everyone. Thanks a lot for attending. As always, I have some great people helping out behind the scenes. Taran always helps out with these streams. Thank you so much, Taran. Josh Molina's out there helping us as well. Really appreciate you guys for helping make Marco and I look good on these streams as we cruise forward. So as far as the community goes, thanks for attending. We love doing these fireside chats. Look forward to doing them again. So take care, everyone. Have a good one.